So the first one has a lot of numbers, but it's really not that hard. This is kind of a classic problem for kinetics all the time in the exams to see. Okay, so we need to determine the rate law expression for the reaction to explain how we do it or show your work. Sometimes you can just explain it. You don't have to show your work, but you need to explain it. If you don't explain it, you have to write down things down to so the TA, when it is correcting, to know that you know actually what they're doing. You cannot just put it down and not explain it if you don't make calculations, right? Okay, so in order to find the rate law, so rate law is going to be equal to what? It will be, the equation will look like this. Rate will be equal to rate constant times A to X and B, Y. Right? We don't know X and Y. That's what we'll find out. You agree with that? And we're going to find out these numbers, X and Y, by seeing how the rate changes as a function of concentration change. Right? And this is apparent when we look at the table. So you look at the table and you try to find out two experiments that the concentration of one of the two is constant. So that way we can see what happens to the rate by changing the concentration of the other one, right? So if you look at experiment 1 and 2, so experiment 1 and 2, what does it tell you? Look, 1 and 2, you have the same concentration of B, but you change the concentration of A. So when you double the concentration of A, what happens to the rate? Becomes what? 4 times. What does it tell us? That the rate is proportional to what? To A squared, right? The reaction is second order on A, right? Okay, great. Now we try to find out experiments, because the problem I have much more, 5 experiments, 6, right? We don't know. Just 2. So we try to find now a combination of 2 other experiments that the concentration of A is constant. So we'll see now what will happen to the rate by changing the concentration of B, right? So if you look, what experiment do we look now? Well, we see these 2 are the same, so that's going to be good then. So experiment 2 and 3 is telling us that the rate is what? Let's see. This is constant, and you double the concentration of B, and what happens? Doubles. Can you see that? The rate doubles. Okay, so that means that the rate is proportional to B. You agree with that? Okay, now we can say that the rate is K, what, from these 2, right? The rate is proportional to A squared times B, and therefore the rate will be K times, when you make it equality, will be the constant, A squared times B. You agree with that? Okay, we know the rate then. Now it tells us to find the rate constant. You can find the rate constant, if you know the rate law, you can find the rate constant by applying any of these 3 lines. So any experiment you use, you get the same answer. So if you go for B, you can go any experiment, as I said before. Let's do it from experiment, let's say 1, will be rate is equal to K A squared B. That means from experiment 1, the rate is 1.0 times to the 5th, minus 5, sorry. K times concentration of A squared from the table, times 1 on 10 to the minus 2. That would give K 250, molarity minus 2, second minus 1. And then it tells you what's the rate of reaction. when you know A and B. Okay, so if you know A and B, you know K, so you can find out how much it is. Okay, so A will be equal to K squared B. A will be 250 times 6.0, 10 to minus 3. If you want to use units, you can do it. They should be working okay. And you should find rate to be 9.0 times 10 to the 5th minus 5 molarity per second. And then we have a fourth question to answer, and that is, yes? Huh? That's the concentration of A from the table. Yeah. But I don't see it. For C. A squared. No, wait a minute, it's given to you. What I'm saying. Yeah, they are given. So for this concentration, what's the rate?
Depends on
so the problem. You take this to numbers of the problem. And the rate constant comes out of it. Okay. Now the D. How do you answer D? What's the answer for D? It's asking us, and it says what? Could this reaction be a one-step reaction? No. Why? That's not the reason. That is not the reason. Why? The question is, if it could be what? One-step reaction. Why it could not be one-step reaction? What is the reaction? What is the equation? That's, you can say, that's improbable to be an elementary reaction. It's improbable, but it could be. Okay. The question is why it cannot be. Right? It's a different story, right? Why it cannot be elementary reaction, single step, one-step reaction. Why it cannot be. We're not talking about probable, right? Thermonuclear, that means 3 order, right? Molecularity 3 collide together. It's improbable. But it says why it cannot be a one-step reaction. Why? Anybody knows? Exactly. If it was one rate, if it was one-step reaction, right? Then the rate, we know what the rate should look like, the rate law. We know what the rate law, the equation, right? How it will look like, because from the coefficients we know how it will look like. It will be what? Rate is equal to rate constant times what? A times B squared. But the experimental is not that one, it's the other way around, A squared B, right? So, it cannot be. It cannot be because the rate law will not match with the experiment, right? Okay. Ready for the other, for the next